Okay, let's take a look at number 15 from 5D. And the first thing is we got to graph this function. And then the second part is domain, range, and asymptote. So when we do that, I'm just going to do A and B together because that's kind of what we do in class anyway. So our parent function is 3 to the x, right? You can see it right here. So I'm going to say I'm going to make a chart for y equals 3 to the x. So here's x, y. We have been using -2, -1, 0, 1, 2. I'll fill this in down here just now. Okay, so remember 3 to the -2 really means to make it a +2, it's 1 over 3. You use the the reciprocal, and so that becomes squared. And then 1/3 times 1/3 is 1/9. It's 1 squared over 3 squared, so it's 1/9. If I just do 3 to the -1, or 3 to just the -1, then that's the same as flipping the 3 to get 1/3 to the +1, which is just 1/3. 3 to the 0, anything to the 0 is just 1. 3 to the first is just 3, and 3 squared is 3 times 3, so 9. The domain is the allowable x values. And if you remember 3 to the x, the base is bigger than 1, so it's exponential growth. And so it starts out low and it works its way up like that. That's what a parent growth function looks like. And so the allowable x values, well, x can be anything, so it's all real numbers. The range is only positive numbers because if you kind of look at this as you go, as x gets bigger, the y's just keep multiplying by 3 and 3 and 3 and 3 and 3. So this goes up to infinity. And as I go down, as x gets smaller and smaller and smaller, I'm dividing by 3. And so it just keeps getting closer and closer and closer to 0. So the range is going to be the y's are bigger than 0 up to infinity. And the asymptote is y equals 0 down here. Okay, so that's the original function. And then to get an intermediate chart, we can look at that -2 in front of the 3 to the x. So this thing right here is related to vertical stretching. It's really two things. It's a vertical stretch by factor 2 and a reflection across the x-axis. So that's equivalent to multiplying the y's by -2. So here are our x's. We didn't do anything to the x's yet, but we multiplied all the y's by -2. So this will be, instead of 1/9, it's -2/9. Instead of 1/3, it's -2/3. Instead of 1, it's -2. 3 turns into -6. 9 turns into -18. But remember, we didn't do anything to the x's, so the domain doesn't change. For the range, we multiply the y's by -2. And so the 0 doesn't change, but when you multiply an inequality by a negative on both sides, the sign flips. And the asymptote is still y equals 0. Because again, multiplying 0 by -2 doesn't change anything. Okay, so now we need our final chart. And in order to get to that, we've got this -4 attached to the x, which means translation of 4 to the right, and then 1 down. And so that means add 4 to the x's and subtract 1 from the y's. So here's our last chart, x. And now this is the final function, which is g of x. -2 times 3 to the x minus 4 plus 1. Whoop, sorry about that. Plus 1. So if I add 4 to the x's, -2 plus 4 is +2, and then they all go up by 1, so 3, 4, 5, 6. And then if I subtract 1 from -2/9, it's -1 2/9. If I subtract 1 from -2/3, it's -1 2/3. And then -3, -7, and -19. The domain, if I take all real numbers and I add 4 to them, well, it's still all real numbers. The range, if I take everything less than 0 and I move everything down 1, now it's y is less than -1, and so my asymptote also moves down 1. So now we have everything we need to graph it. So here's the graph. Let's see, most of this stuff, x's are positive and y's are negative. So that would be like mostly in this quadrant down here. So let's see, x's go up to 6. So 1, 2, 3, 4, 5, 6. The y's go up to -19. How do I want to do this? I go -2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, so let's see, asymptote at -1. So I'll draw that right here. Y equals -1. And then when x is 2, y is just a little bit more negative than that. And then when x is 3, it's a little bit further down, but not quite to 2 yet. 4, -3 would be like around here in the middle of 2 and -4. 5, -7, 2, 4, 6, 7, around here. And then 6, -19 would be like down here somewhere. And so then you should be getting the feel of how this looks. And it's going to hug the asymptote, go through our points, and curve downwards here like this. Okay. So this is the graph that answers part A. So here's part A. The domain, range, and asymptote equation are over here for part B. C says find the inverse. Now this is tricky. This is a little bit weirder. We've done it a tiny bit, but not a ton yet. So let's see here. I'll do this in black again. So the original equation is y equals, if I change the g of x to y equals -2 times 3 to the x minus 4 minus 1. And now that means that the inverse, I'm going to switch my x's and y's. Whoop, sorry about that. So let's see here. Now I'm going to have to get y by itself, and it's an exponent. So the way we get exponents out of there and just isolate them is by using logs. So we're going to need that. Whoops, sorry about that again. So the first thing I'm going to do is try to isolate this term. So first I'll add 1 to both sides to get this. And then I'll divide both sides by -2. So then we get, oh my gosh. So then we get x plus 1 over -2 equals 3 to the y minus 4. And at this point now, even though it might not look like it to you, it's in this form. Let's see. How do I want to write this? A equals b to the c. And we've learned that can, and we need to get the y minus 4 is the c here, if you can't tell. And we need to get that out of the exponent because we need to get y down below. So what we can do is rearrange this into log form, which turns into log base b of a equals c. So over here, this is going to turn into log base 3 of a, and a is this whole thing, equals c, and c is y minus 4. And now if I add 4 to both sides, I get y by itself. And that's the inverse. So the inverse of this exponential function is this log function down here. And then I think there's one more part. Find the domain, range, and equation of the asymptote for the inverse. Oh, this should say in C, not in B. Okay. So let's see here. The original, the domain was all real numbers. The range was y is less than -1, and the asymptote was y equals -1. So for the inverse, if we switch x's and y's, then now instead of y is less than -1, it's x is less than -1, which means that's the domain, because domain is x's. And the asymptote has changed from y to x. So now it's x equals -1. And then the domain for the original used to be all real numbers. So instead of x being all real numbers, now it's y is all real numbers. So that's our new range. So here is that info for the inverse, which now we can say also these two go together, right?